All right, well, so class, we're gonna get this started, and thank you, Nigel, for joining us here at Scheduler College, one of our classes, and planning this big boat project. I know you've been super busy, so you probably haven't been watching the 40 plus videos we've put out on this refit. Haven't run out of money yet, but we're getting close. But when we sell it, we would love somebody to be able to buy it and do a 7-year circumnavigation. And so when it came to the electrical system, we started bringing in some questions. And so I was going to run a few PowerPoint slides to kind of give you, it's really fun. We sit around the break table or up on the boat and in little conversations about what would you do if it was yours and what would you do? And, and everybody's got opinions and, some good, some bad. And so we appreciate a little outside view to get us outside of our bubble to make sure we're not screwing this thing up.
Well, you have to excuse me. I'm going to eat while we talk.
That's all right. You can have a glass of wine and your dinner. It's late.
I already had a glass of wine. It's 7 o'clock here in Maine.
Yeah. The crazy part about Zoom is go around the world with this stuff.
Right.
So, all right. So this is what we were talking about. And I can kind of, while you get some dinner going, you can follow along here. So King's Pride, somebody give me a thumbs up. Are you seeing the slideshow? Thank you.
Yeah, we can see it. I can see it.
So there's our boat, the West Sail, sitting out back, and this is some of our crew here. COVID's been bad, and this was really not a good year to do a refit, but we're getting by. So
the hull and deck are pretty sound, Mike?
Very sound. We had a surveyor, a student of ours, a surveyor, came and knocked all over the deck, and the core is dry. She's solid.
Wow. That's unusual.
It is. We're going to the Roger King, who built it. He sealed up the edges. He didn't eat all the core out, but he seemed to have sealed the edges of the balsa real well. So anything that leaked came inside and didn't saturate the core. But we got to have the bottom sandblasted. It's got a whole bunch of too much bottom paint things, and we're putting new windows in. They're cracked, and so just stuff like that. But overall, it's going to have the tanks we've taken apart from your advice from when we've taught diesel classes, and Art knows, he's been around boats many years. We've got both tanks have been out of the boat, suction ports cut in them. They've got a stripping port at the very bottom, and then we came up a little ways for the fuel supply. And yeah, the tanks are gonna be good. The engine's new, prop, shaft, all that's gonna be new. The rig is all new. We've painted the mast. We haven't put it back on yet. All new standing rigging. It's a proper half-life refit. Is what I call it. So on the electrical side of things, basically we wanted a DC kind of a simple boat. I've been a big fan, as you know. I still have my 4 original Fireflies. I've only killed one of them, and I have run them through the ringer. So I really think for something that's just reliable and going to go, that we should put on Fireflies, and 3 of these 4-volt cells will fit in where the kind of the battery bank is. It's giving us 450 amp hours. We'll throw in a engine start battery.
So Mike, let me interrupt you there.
Sure.
Can you put those in on their side?
Yes, we actually have to. Art made a mock-up last couple days. It's the only way they fit.
So make sure when you do that they're laid down so that the plates are horizontal, because
is that the long axis down or the tall axis down?
You'd have to look at the battery posts and figure out which way the plates are inside the battery.
It's the tall side up, I believe. We got a junk one.
Not this way.
I can check. I got some pictures. I chopped some of them up and checked, because we've had a couple of failures, and I suspect there's a weakness in the way that the foam plates on the negatives plates are tabbed into the bus bar, and that when they're vertical, I think, and they're pounding, I think they can crack that. But when they're laid flat, as long as the plates are horizontal, then there won't be any stress on that tab.
Okay, good. That's great advice. We'll we actually have one here we could chop up too, if you don't find your pictures. So so that was our plan. Put a group 31 up forward for the anchor winch. We're thinking we're just going to charge that with a 12 volt battery charger, so we don't have to run big cables. Should keep the anchor winch plenty happy. We're targeting like 170 amp alternator. We'll get a hold of Bruce Schwab. You guys been doing a lot of alternator testing. There's some nice ones out there. We've already got Wake Speed has donated us their regulator, so we.
If you can talk him into it, you should go for the higher powered alternator. He's got a 12-volt one that's.
Isn't it like
3.6?
3.6 kilowatts?
Yeah.
That's crazy. So
Well, those Firefly batteries at a 50% data charge and below you can charge them at the 1C rate. How many amp hours you can have? 450.
yeah.
So yeah, you can pump 200 or 300 amps into them right up to about 60 or 70% data charge.
Excellent. Well, with
And actually the reduction in engine runtime, if you figure it out and you look at the amortization cost on your engine, will more than pay for the additional alternator cost.
perfect. That's why I want to do this. We're gonna start. This is where I am the purchasing agent. I have to manage all the money and get all the equipment. So that's good. We'll get a hold of you. And of course, the boat will have some solar on it, and the propane in the galley. So we don't have a ton of loads. It's just we're targeting it for two people to just go out and sail.
So on the solar, are you going to use semi-flexible?
We're going to put 2 semi-flexibles on top of the hard Dodger. And then one of the things we're doing with the boat is it's not going to be 100% done because we don't have the time and the resources. So the new owners, whoever buys it are going to do things like put on, new canvas. They can pick their color. They can work on the bigger array if they want to. If it was ours, we'd put some sort of an arch with more solar on it. So it'll just have a couple of smaller panels on top of the Dodger when it goes out the door. But we'll scale
if you can afford them, you should take a look at those SR Plus, not the SR, but the SR Plus panels Bruce has, because they have a very interesting bus bar system inside the cells. So there's actually 2,000 connection points on every cell between the bus bars and the cells. They've driven pickup trucks over them in testing and crushed the cells and still recovered 70-80% of the output because there's so many connection points on the grid structure.
Oh, really?
Yeah.
Okay.
So for a marine application where you've got flexing and stuff, it makes for an extremely rugged structure. Plus the cells themselves are the most efficient on the market. They're a Panasonic hit cell. It's a Hero, whatever, I can't remember. It's some long acronym.
Do all those connection points also help you in the chance of getting shaded by things like your boom and other things?
No, that's a cell issue. If you shade the cell, it knocks out the rest of it. But it's and it's not just on the cell itself. The interconnection between cells, the series connection, there's hundreds of little connection points. It's a really clever patented connection system. We just happened to find out about and got panels made for the boat market. But it makes them extremely rugged, and they're also the most efficient panels on the market, and they're actually cheaper than the Solby and SunPower panels.
Wow. All right. Well, I'll have to measure that up because we definitely want to start with a couple of those and get it going.
Oh, and I don't know if you know this, but in the solar world now, they have these boost regulators. So because the cells are like 6 inches square or 5 inches, in the past, when you wanted a smaller panel, you had to chop the cells up into smaller pieces to get enough in series to get the voltage. Well, now you don't worry about it. You maybe even got room for 9 cells. You put 9 of them in there. You get 6, 7, 8 volts out of it, and you put a boost regulator on there to put it up to whatever voltage you want. Significantly improves the overall efficiency of the system.
Interesting. I did not know that. I just knew
No,
about
I only just found that out recently.
Excellent. Well, I'm taking notes, stuff for next quarter, we started with the basic, we drew out a kind of an outline of basic circuits that we're going to need and on the DC side of things, and that isn't too difficult. AC, we started talking about what would be the minimum kind of things, and with trying to keep the boat, sellable and attractive to as many people as possible.
Oh, and you think an ice maker is essential equipment?
Well, yes. Gin and tonics, they're just not the same without a cup.
That's a very American perspective.
Well, and you notice it's countertop. Those are those little tiny ones that you could just add. And so a lot of people out here are running those. They're running the little Instapot electric cookers, stuff like this. computers,
Yep.
gadgets. So we really weren't thinking too much. And that's why I wanted your perspective. So any, a multi-plus like this from Victron would run that equipment just fine. The
So,
snag,
we have exactly that system on our boat. I have had for the last 20 years, 30 years, with a 3 kilowatt inverter. And we have electric hot water heater. That's about 800 watts. They don't take that much energy. And a microwave. But we don't have air conditioning. If you don't have air conditioning, a 3 kilowatt inverter will drive all of these AC gadgets that you want on the boat with no problem at all.
yeah, that's what we were kind of thinking. And then in our neck of the woods, though, we think about adding a couple stuff. So, which is, air conditioning or electric heat, just to take the chill off. Ultimately, it depends on who ends up with a boat. If they're headed for the tropics, they're not going to need heat. If they want to go to some of the, higher latitudes, then probably they should install a diesel furnace. But for just living aboard at the dock for a few weeks here or there, going to explore, we were thinking a little electric tow heater might not hurt, or maybe a small air conditioning unit.
Well, you can run both of them up a 3 to 5 kilowatt inverter.
Inverter. That's what I was thinking. And then I don't know. This is why we wanted you. You've got a lot more experience in Europe, especially, with overloading shore power cords and stuff.
Mhm.
But we really think that if the boat's going to leave here, if we have the opportunity, we'd like to be able to plug it into 240 volt 50 cycle or the 126.
Yep, we've done that for the last 20 years, Mike. And we've
Okay.
always wired the boats for a 120 because it, takes a bigger cables. So they're American built boats that we run in Europe for. We have a single shore power inlet, the standard US 30 amp 120 volt inlet. And we have 2 shore power cords, one for the US and one for Europe. They have the same boat connection. You don't need 2 inlets, you just need the one inlet. And then you just need a different plug on the other end of the cord, one for Europe and plus the European one, of course, being 240 volts and 16 amps, the cables are much smaller. So it's quite a light cable. And you could use the same American one with adapters, but it's just easier to have 2 separate cords. And then we have a universal battery charger, typically speaking about 2 kilowatts, so that we don't overload the shore power cord. And then we run everything, all the AC equipment on the boat off an inverter. We don't have a special separate inverter panel. It's all the AC equipment is on a single panel that runs off the inverter. And we have to practice a little bit of load management at times, but that's no big deal. It works great.
That was one of my questions with load management. And we need to assume if somebody wants to take off and be a cruiser, that they should be able to manage some load for sure.
A little bit, yeah. It doesn't take much. And then the big advantage to doing that, any marine battery charger is built around an isolation transformer. I mean, that's inherent to the Charger. So if you don't bring the AC grounding cable on board, I mean, if you stop it at the battery charger, that's the end of the AC circuit. Short power circuit is the battery charger. You've effectively got a isolation transformer on the boat, and then that gets rid of the corrosion issues associated with the short power grounding cable.
This was my little sketch of, what we could do with our Fireflies. And so you have around 2 kilowatts. The little bit of research I did, Victron's got 100 amp at 12 volts. I don't know. I thought Mastervolt had a bigger one, but what brand do you have on?
Right now I have Victrons. Well, no, because we have a 48 volt system. Yeah, we're using a Victron 48 volt inverter charger as the charger in Europe, but of course it's not a universal input because it's an inverter charger. If we brought the boat to the States, we'd have to put a different charger on there.
This was what I came up with was, we could just have a regular hull inlet like you have, the USA version, a battery charger, and then everything runs on this 3 kilowatt inverter. I'm kind of a fan of the Victron stuff. We've been putting in a lot of it. I just put one of these on my boat. And the beauty of it is, as you said, somebody could expand the system. If they wanted to run more AC loads or add more charging, they could daisy chain these products. And,
well, and the other thing to remember, Mike, is that when you're plugged into shore power, that's a continuous source of power. Even if you've got 100 amps, so that's about 1.2 kilowatts. If it's running all the time, that's 24, 25 kilowatt hours available over the 24 hours. So even if you've got 2 or maybe 5 or 6 kilowatts of inverter loads on there intermittently, it doesn't matter because the batteries will just get discharge a little bit, and then when the loads turn off, so you don't really need to upgrade the battery charger. The 100 amp will be fine. It'll keep up with pretty enormous loads on the boat, and the batteries will just get cycled a little bit every day.
Sure, but I don't think that's the end of the world. You know, the hot water heaters don't run for 20, 30 minutes, right? To heat up 6 gallons of water. That was the idea. The one thing I didn't like is I do like all of the battery charger and the load assist features and stuff that the inverter has. You don't get to use in this system.
No, you can't use any of them. Yeah.
Well, I'll bring that up in a minute. You know, you could expand this with money, and or if there's enough space on the boat. So I just said that's an option.
Yeah, but as I was just saying, I don't think you need the second battery charger,
Just
because you're not going to burn through 20 kilowatt hours a day. You're going to maybe burn through 5 to 10.
On
The
average,
intermittent high loads, the battery charger will catch up over time.
yeah, and so that's the cool thing in the last however many years is these new chargers that will take any voltage or frequency. I think these take like 80 to 280 volts or something.
Yeah, and also 45 to 70 on the frequency.
One of the earlier designs I had, and I just have it up there because I started with it. I just wanted to know conceptually if it would work. It's not our desired outcome, I don't think. But in order to optimize shore power a little more, I had wondered if you took a transformer and just brought in 120 or 240 volt and put all 120 out, couldn't you run your hot water heater and a tow heater on that system? They'll run on 50 or 60 cycles because they're just a purely resistive load.
I think that's unnecessarily complicated.
I think you're right. And that's when I started drawing the pictures and I'm like, well, this would get us more out of the shore power, but I thought it was complicated. So we went back
to go straight to the battery charger and then run everything off the inverter.
Yeah.
Now,
so
of course, you've got like 15% losses in the charger and 10 or 15% in the inverter. So you've got compounded losses there, but who cares? Because you're plugged into shore power.
That's right. Yeah, you're plugged in, you're paying for it. It doesn't really matter at that point. So we went back to kind of this thought about, okay, all we need is, a decent battery charger, a decent inverter, do a little training with the owner about power management on the AC and keep an eye on their batteries. My next thought was, because like I said, I just installed one of these a few weeks ago and we're installing one here in the lab. And I really like the charge features and the power management, where with the Victron system, you can see your solar, you can see your shore power. And so I wondered about, it's not too complicated, I don't think, or that much extra cost, about putting in a little double breaker so that when we're in the States, we could run the shore power in, utilize the inverter and all of its features. And then when they cross the pond, you just turn on the battery charger and let it do its thing. So
yeah, I think that's also a great way to go, because the other advantage there is you've got the pass-through mode on the inverter in the US. So you get rid of all of the serial losses between the charger and the inverter.
And that pass-through will allow the boat to pull up to 50 amps if somebody did, by using some battery power.
Yeah.
If they wanted to put an air conditioning unit on and it cycled on right when the hot water heater was on. And realistically, the boat's going to be in the States for a while for shakedown crews, and somebody's got to go a ways before they even find the 240 volts. So
Southern Hemisphere, I think.
You might, if you're going to load up the AC side, might want to put one of those smart plugs on the boat end of the thing. I've seen a lot of burned up shore cords, not the cords, but the connectors.
Actually, it's coming up in the next slide or two. I did my cost analysis. So I spec'd out buying a smart plug cord and hull inlet. And I was surprised these little Victron, they make a little, with their name on it, one of these hull inlets, and it was only like $45 or something. It wasn't brutally expensive. So you think you'd give this system a thumbs up for simplicity? Yeah. It seems like it'd make the boat run. And
yeah, no, it'd be great.
The nuts and bolts of it then. So we when we bought this boat for $25,000, we said, $15,000 for the motor and $10,000 for the rig and $10,000 for electric, and just off the cuff. And so now I've been watching the pennies and nickels and dimes. And if you price this out at Fireflies and just a basic 170, now this is much cheaper than, if we could swing that bigger alternator, it'd be awesome.
Yeah, you're talking a
Um,
couple of $1,000s retail.
Yeah, I know they're expensive. So,
Yeah.
but maybe we can get somebody to give us some love and should get the college one at cost or something.
The other thing you should do is an analysis of what it does to the efficiency of the system and the cost of energy. I think you'll find it's actually a worthwhile investment, and it would be a good exercise to go through.
Yeah, I think so. It especially, well, as you know, if they're doing any kind of charging at anchor, if they stay someplace and they're snorkeling and hiking for 3 or 4 days and, they need to light off the engine because this is a non-generator boat. Being able to put out 3 kilowatts or something would be spectacular.
And then you could get your students there to do a crankshaft pulley load analysis, because that's going to become increasingly important that we understand these things as we get into these higher output alternators.
We've got a little pickle fork built and we've got the load cell and we've got the plan. We're going to get that bit of research done sometime. If we weren't building this boat, we'd have probably been done with it already. So yeah, smart plug, couple of hull inlets, selector panel. I came up with around $8,000. So, and of course we need wire and OCP and a DC panel and da-da-da. I don't think it's too far off from a $10,000 estimate for equipment to buy that, most of that equipment.
But what I've learned is that you double your estimate and then you're only 50% off.
Yeah, we found out that to be kind of true. We were hoping to have the boat quasi ready for the next owner for 75,000, and I've already spent 71,000. So we're gonna put probably at least 90 to 100 into it.
Yeah.
But it's
and
a
that's
boat.
without the labor.
Yeah, there's no money in refitting boats, I don't think,
No, none whatsoever.
But the experiences that our students are getting, the what we like to do, that's kind of priceless. We'll be able to recoup our money, and that's what my boss said. That they don't care. We buy equipment, if we sell it and break even, we can start again. I'm sure we'll make a little money on it. But
yeah,
well, excellent. So what do you think we've forgotten?
I'm not sure.
That's good. Well, nothing popped up into your head.
So there's there's the corrosion issues. Obviously, you'll need, especially if you do the pass-through mode on the with the two inlet system and the battery charger and the inverter. When you're in pass-through mode, you're going to bring the AC grounding wire on board the boat. So then you're going to have at least a galvanic isolator in the system. And
the other thing we haven't done yet, I guess on DC loads, is if they want to do the below deck autopilot, that's quite a bit of a load. It's got a wind vane, half of the wind vane. It only has the pole part. It had a hydro vane on it originally, and then they sold off that. So, but I'm assuming that this boat would probably have, a hydro vane put back on it to keep the DC loads down when sailing. But
yeah, in practice, we've had a monitor on the boat for 12 years. We've used it twice, I think, because it's so easy just to switch the autopilot on. Probably the average load on the autopilot, if the boat's reasonably well balanced, is about 5 amps or 12 volts, 60 watts. So it's not shocking. And then the rest of the electronics, so presumably somebody's going to want a radar at some point, probably going to, especially if we've got a big, large format MFD, it's probably going to be another 5 amps. So the at-sea load is going to be significant. That's actually the greatest load on our boat, is when we're passage making with the autopilot running and all the electronics on.
Yeah.
Probably adds 20 amps continuous with everything.
15 to 20.
Yeah.
And that's why that big alternator is worth its weight in gold, because the time it takes you to pull up the anchor or to get on the dock or whatever, you can replenish much of that energy. Of course, when we get to the integral system, we can, in 20 minutes, we can put enough energy back in the batteries to run the boat all day.
Right. If we get a trust fund person to help us out with the next boat we will do lithium batteries and the integral system. And
right. Yeah.
We're on a shoestring budget for this one.
Right. Right. But it's worth investing in the alternator. I mean, that's because if you think in terms, let's say what are you budgeted for the engine? 15,000.
Yep.
And realistically, with labor and stuff, that's 20 or 25. It's got a life expectancy of 5,000 hours. So it's $5 an hour, regardless of whether it's doing any work or not. And then you have a small alternator on there. and you start running the arithmetic, and you discover you're paying $10 a kilowatt hour for electricity. So you double the output of the alternator, that drops to $5 a kilowatt hour. It doesn't take long to pay for the additional cost of the alternator.
The alternator, yeah, just on engine runtime. And also, this boat doesn't have unlimited fuel. So that's another 45-gallon main tank and a 30-gallon auxiliary, I think. So 75 gallons of fuel. So you don't want to be endlessly running the motor just to charge batteries.
And if you're battery charging an anchor, and you can double the alternator load, you radically improve the fuel efficiency of the engine, because when you're with a low load at battery charging an anchor, the engine is chronically inefficient, and it doesn't take much additional load to shift the fuel efficiency up really rapidly. So you gain at that end as well.
Yeah, I think that makes sense. I'll definitely chat with Bruce about seeing how big of a, we'll buy the biggest alternator we can afford. Well, the batteries will take it, at 12 volts. We are going to put in a
So sorry for interrupting, but the Fireflies there, I wouldn't have any qualms about if you are like battery charging an anchor and you've got a decent sized alternator, the battery charge acceptance rate is going to drop, below 100, 120 amps when they're maybe 65, 70% charged. I would have no qualms about running those Firefly batteries between 20% and say 70% state of charge for weeks at a time.
That's why we're going with them. You told me the story. You left yours sit half dead one whole winter and they tested just fine. Yeah, so we're going to put a platform in for the autopilot for a below deck, even though we're not buying the unit. We had to move the motor mounts and stuff. So we're doing some fiberglass work. So we're going to make provisions so somebody can put in a below deck autopilot and have the hard part done.
Yeah, that's a really useful piece of kit on a cruising boat, is a decent autopilot.
All right. Well, I do appreciate all the looking it over and making sure we're not too crazy. You never want to go down 3 months worth of work and realize you made a mistake, have to backtrack. Does anybody else in the class have any questions you want to throw out there?
Silence.
Crickets. They're all in
Nigel, you're talking about making what am I trying to say? With the battery charger, you were saying that could kind of act as a isolation transformer. Is that just because you're taking AC power from the batteries, basically?
Basically,
okay.
Your shore power circuit is stopping at the battery charger. That's basically the only thing that's wired to it. And then everything on board, AC, is then coming off the inverter, which has been powered by the batteries. So it totally separates the shore power from the boat AC circuits. Technically speaking, from an ABYC perspective, you still have to connect the case of the battery charger to the boat's DC grounding system, the common ground point. Although most of those battery chargers don't even have a connection point to do that. But even that doesn't void the isolation transformer. So it effectively gives you an isolation transformer at the cost of a battery charger. And it works great. I've done it ever since they had those universal battery chargers, at least 15 years now. And it gets rid of all of those corrosion issues that come on board with the shore power cord.
So would that be cost effective to do in the States, or would that just be something that you would do since you're going to Europe kind of stuff?
Oh, no, it's cost effective anywhere. I mean, regardless of where I was building a boat, I'd do the same thing. Now the one, if you've got air conditioning on the boat, then obviously, if it's high load, you may want to bring the shore power onto the boat to power the air conditioning. But even there, if you've got a decent shore power, let's say you have a 50 amp connection in the States and a couple of big battery chargers, and these Victron inverters now, you can stack them up to 20 kilowatts. There's no reason why you can't use the same philosophy, even power significant amounts of air conditioning.
Excellent. Yeah, I don't see why not. I mean, a little extra cost on the battery chargers, but
they're not very expensive, battery chargers, in the overall scheme of things.
Yeah, well, it all seems to add up, though, come to find out. I just realized on my cost sheet on that, I forgot about the inverter control panel and all those.
Right. The systems monitoring.
Yeah, so there's going to be
and
there's always a little extra cost, of course. So that's
right.
That's all right.
So have you gotten to play with any Hall effect shunts yet?
No, not on DC Hall effects.
Yeah, all the integral system uses those. I don't know if they're available with other systems. It's that's the way we're going to go in the future, because you don't have to cut the cable to install the shunt. You just run it through the hole in the middle.
Yeah, no, we just been using the new Victron smart shunts that you could Bluetooth to your phone and
Yep.
be part of the network, but we haven't got into beyond that yet. Lots of fun stuff, that's for sure.
Yeah,
All this connectivity and digital switching and the whole systems just seem to be, and I don't, for better or worse, you know, they just keep adding a whole lot of stuff. So some of it's definitely better. Some of it I think is too complicated. So
yeah. I mean, the main thing is to keep that at the monitoring level, so that if it fails, the core systems still function, and you can get out your multimeter and see what's going on. Particularly on a cruising boat, I mean, you want the basic core systems to be pretty bulletproof.
yes, so that's kind of what we're hoping for on this boat is, you know, it's 39 feet. You can handle it with two people. Try not to put anything in there that's going to overcomplicate it or have single point of failure that's going to you know, end somebody's cruise. So,
Yep.
Or worse yet, have somebody get hurt, you know. All right. Well, you got your plans in May to go to your boat, so that'll be good.
Yes.
We got one more quarter here, spring quarter for these students, and they'll all be getting certificates and or degrees and heading out for summer jobs, working on boats. So you have any words of wisdom about mucking around on boats for new technicians?
Yeah, if you want to make a decent living, get into some other field. No, it's great to see you guys doing this. There's an incredible shortage of skilled technicians in the boat world at the moment, and especially people that actually enjoy doing this. There's a future in this business finally, and not only that, it's fun.
It is fun, that's for sure. So, well, I hope maybe next year we can get you to come to Seattle for the boat show and sign student textbooks again.
Sure, love to.
The 4th edition is the final one, isn't it? I've been telling them there's no more editions. Is that correct?
No, I don't think I'll do another one. It's just too much work.
All right, Nigel. Well, I'll be wise of your time, and thank you very much. And enjoy your evening, and we'll stay in touch.
Well, good luck to everybody.
Right. Thank you.
Thank you, Nigel.
Thank you.
Thank you.
All right.
Thank you.
Bye.